Right, guys, so we're setting up forces left versus forces right for the position of equilibrium. The force to the left is a 5 Newton, the K value is 5, the extension is x, and the natural length is 1, while on the other side the K value is 3, its length is 19 minus x, and its natural length is 2. And now we're just going to put this through here. We've got 5x minus 5 equals 3 times 17, which is 51, take x, bring it to the other side, and we get 6x equals 56, is it? Oh, sorry, minus 3x, thank you. So it's actually 8x equals 56. 8x equals 56. If you've got an x value of 7, that means it's located 7 meters away from the left wall or 12 meters away from the right wall, yeah? Find the point where the resultant force of the magnitude is 16 newtons acting on the particle to the right. Acting to the particle on the right, 16 newtons. Okay, so what you're telling me is FR minus FL is 16. What does that mean? I think that means we have to bring it to the, what position would I move the red particle, left or right? Think about it. It's 16 newtons acting to the right. So I need to stretch the black string more, don't I? So I need to bring it further away from the wall. That's what's going to go on here. Let's go further away. And then there's a net force on the way back. Okay? So what we're going to do is what we did before. The force to the right is 3 times. And we're going to use, the deal is, we're going to disregard the x answer from the first one. You happy enough with that? Disregard the x answer from the first one. I'm just going to redo this, okay? So I'm going to make this starting from scratch. Sorry, black, 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 red. It's still x and 19 minus x. Is that okay? So I need to figure out what length is this from the left wall. Okay? So force right is going to be 19 minus x minus 2, as it was last time, minus force left, which is my 5 times my x take away 1. But this time they're not equal to each other, because you know that force right is 16 bigger than force left. You multiply it out, and did everybody get 51 minus 3x minus 5x plus 5 equal to 16. Bring the 8x over to the other side and do 51 plus 5, which is 56, take 16, 40, and then x equals 5 meters, which means it's 5 meters away from the left-hand side wall. Any questions about that one? The deal is a particle of mass 1 kilogram is attached to one end of an elastic string of natural length 1 meter and elastic constant 50 newtons per meter. The other end of the string is fixed to a point on a smooth table. The particle moves in a circle of radius 2 meters. Find its angular speed. So I'm going to use a parallelogram to depict the table. Here's my parallelogram. I'm going to use an ellipse to depict its circular motion. And then I'm going to have it here. So what's happening is, see this black point? That's its fixed position. That's where it's fixed. The string's nailed in there, yeah? And then what happens next is we have our string, which is the dotted black line. And at the end of the dotted black line, what is there? A 1 kilogram mass. You go with that? What's the radius? What's the radius of the motion? Meters? Okay. What do we learn about circular velocity? the tension has to act back towards the center of the circle, yeah? So the T value is K times L minus L0. What's K? 50. What's its current length? Current length, guys? What's the length of the string? The dotted black line is the string. 2. What's its natural length? Therefore, the answer is 50 newtons. Now, what's the goal of the question? Find its angular speed. Does anybody remember the formula for angular centripetal force? mR omega squared. Replace m with 1, r with 2, and omega. And who got omega squared equals 25? Sorry, omega squared equals 25. Therefore, omega is 5. Anybody remember the units for this? Rads per seconds. Means radian. So, the deal is a particle is hung from a ceiling, and obviously, because it has weight, it's going to drag the string beyond its natural length. You all right with that? So, when you're using the formula F equals K times L minus L0, it's technically the same thing as K times extension. Would you agree with that? They're actually the same thing, right? And what we're going to do is we're going to figure out what's going on with this, all right? So at the equilibrium position, what can we say? T going up equals 2G or 19.6 newtons going down. Would you all agree with that? So T equals W, which means K times L minus L0 equals 19.6. What do we all say K is again? K is what, guys? 7. What's the total length of the string? And then take away 2, which is just 7 times. X equals 19.6. This means the X value is what? 19.6 divided by 7? 2.8 meters. Now, that's not the question, though. What does it want from me? The answer is not 2.8. The answer is actually, why is it 4.8? Because you have to add the extension to the existing natural length. So the answer would be 4.8. Okay. The particle is then stretched a further distance x. Show that the force on the particle is of magnitude 7x over m. This is going to be interesting. Okay. What happens when we pull it further? When I grab it from its position here and I bring it down even further. What's bigger this time, up or down? Up is bigger, isn't it? So we all agree there's a net force, and the net force is upwards, and the net force is tension take away weight. Agreed? What's the formula for tension again? K times what? L minus L0, or K times extension, yeah? And that we have to take away the weight. So what's the weight? 19.6. And what does it want from me again? So it just wants the net force. Okay? And that's pretty much what I'm showing you at the moment, isn't it? So net force. Now, bloody hell. Now, okay. I think I'm going to use the extension, all right? We already know the extension is. The current extension was 2.8. And what happened then? We extended it further, x. So would everybody be happy with k, which is, what is k again? 7. Would everybody be happy with 7 times 2.8 plus x minus 19.6? Guess what happens when you multiply that out? You get 19.6 plus 7x minus 19.6, and the whole answer is, what's the whole answer? 7x. And that's what we're asked to prove. Okay, annoying. So, what happens is, a conical pendulum consists of a particle of mass m attached to an elastic string of natural length 3, which is fixed to a point P at the other end. If the particle rotates in a horizontal circle of radius 3, the center circle being 4 meters directly below P, show that the elastic string is extended 2 meters beyond its natural length. We're just going to do Pythagoras' theorem. And what length is the string then? Would you all agree with 5? And what's 5 take away the natural length of 3? 2. Is everybody happy with part 1? Happy enough with part 1? Okay, great. Stretch 2 meters below its natural length. Show that the elastic constant is, show that the k value is 5 mg over 8. Okay, let's do this. Is this particle supported by a table, or is it being like sort of like lassoed? No, sort of like that, isn't it? Okay. So in that case, mg goes downwards, yeah? And it's t going in this direction here, yeah? And look, actually, why did I do it that way? Yeah, you'll figure it out in a minute. Okay, here's what we're thinking. So, tension equals k times extension. And what's your extension? Would you all agree with 2? Everybody happy with 2? So what does that mean T is? T is 2k. Now, do you remember we would have done this back in the day? I'll pull it back as T for a second, just to keep everything consistent. Would you remember that this one here, see the black line? Would you all say that the black line is T sine theta? Going upwards. What would you all tell me the green line is? Yeah. And what is T cos theta? 3 over. Do you agree it's 3 over 5? Using the other triangle? That's theta as well. So it's 3 over 5 t. And what about sine theta? 4 over 5 t. Okay. Let's do forces up equals forces down, because it is motion in a horizontal circle. So what do we think? Four over 5 times t, which is actually 4 over 5 times, equals mg. Here's hoping I'm getting this right. Yeah, we're about to get it right. Isolate k on its own, and it's 5 mg all over 8, as per part 2. So what does one from part 3? Show the angular speed is root g over 4. So remember, it's a horizontal circle, which means we're talking about that 3 over 5t right there, aren't we? We're talking about the 3 over 5t going towards the center of the circle equals m or omega squared. What do we say about t? T is the same as 2k And 2k in turn is the same thing as 5mg over 4. That's what happens when I multiply it by 2. The 8 turns into a 4. So I subbed in the 2k. Now what happens? What's the R value for your circle? 3. Now I just have to isolate omega squared, don't I? Let's see what cancels here. 3 cancels with 3. M cancels with M. 5 cancels with 5. Hell, everything cancelled. And then what do we have?